Okay, so we have an exercise that's going to let us get hands-on with each piece of the Bitcoin network. So we're just going to do a simple transaction, sending Bitcoin to our own address or your own address, and it's going to give you a lot more context with each of these items in the Bitcoin network before we go into them in a lot more detail in future videos. And after we receive, or during the process of receiving our Bitcoin, we will go into some high-level details of each aspect of Bitcoin, the Bitcoin network. So the place to start, so this is bitaddress.org. This is the place to start. And as you can see here, you're just following the directions, moving your mouse around. You can type in some random characters on this this little input box. You keep moving your mouse around, and what you're doing when you're moving the mouse around is you are creating randomness, and behind the scenes bitaddress.org is making your private key for you, and it's including sufficient randomness inside of your private key, the right level of randomness that you need. And after a bit, you're going to get here. This is your secret and public key, and you can look around at these other tabs and what they mean. But really, all we need right now is just the single wallet, and so that's all we need right now. Move this away. Okay, so again, you end up here with your private key and your Bitcoin address. And also just to note, what we're doing is, the point of what we're doing is just to get hands-on, to increase learning. I found what I think is the simplest, easiest, and cheapest way to do that. So there are a number of important topics that we will not be covering today, and that's fine. Just use a small amount of money, $5, $10, $10 max. So for now, pause the video until you've gone through bitaddress and you've generated your own secret key with corresponding Bitcoin address. So pause the video and do that. Okay, so now assuming you've done that, and to go back and to do a recap, what your private key is just 256 bits. It's 256 random zeros and ones. This long string here, there's just a certain format called base58 check that it's displayed in. And this is either going to start with a 5, a K, or an L. There are some other formats out there you might see, but this is what you need to have today. This is also quite common. And then your Bitcoin address over here, you might hear this referred to as your public key. This point here, X, is technically your public key. And then we have an intermediary step where this is called your public key hash. What this address here represents is the base58 check encoded version of your public key hash, which is a hash of your public key. This is just a user-friendly way to display your public key. It also has some built-in error checks and user friendliness. So now moving on to the fun part, your Bitcoin address right now and the private key that created it, they're not doing anything on the blockchain. So I'm going to show this to you now. This is the blockchain.com Explorer. So you type this into your browser. Oh, I like your drawings, bud.
It's not just one. There's more than you expect.
More than I expect.
I
will take a look at them. So type this into your browser, or you can just go to blockchain.com, or you just go to blockchain.com. Whoops, going out of order. Or you can just go to blockchain.com and find the Bitcoin button. Click on that. You'll see what look like blocks here. Just click on one of the blocks. And I go down to one of the transactions. I open it up and I click on an address. This address starts with a 1. And that brings me to an address in this block. This one's got a lot of Bitcoin in it. I just double click that address and then I paste in my own address. So that's how I get to it. So do that with your address and you're going to find that your address is not on, your address has a 0 balance on it. And the excitement really is not going to start until you use this address to receive Bitcoin. So what I used Cash App and Venmo to go through this. If you already have an app that can send Bitcoin to an address, that's going to work. just fine. So the first step is to just simply get some Bitcoin. And you can do this on Venmo and Cash App. And this is just showing Venmo, but the process will be similar. Just find the Bitcoin asset, click on it, find the buy button, and then within you can exchange your US dollars for Bitcoin. And again, $5 to $10 is all we need to do right now to get hands on. And for step 2, sending Bitcoin, the second step, what you're looking for now is you're going to be within your Bitcoin asset and you're going to find the option to send it. And you need to arrive at a screen where it's got an input form for a send address. And most likely it's going to have up here in gray the words BTC address, something along these lines. Maybe even a QR code. You can scan the public address from bitaddress.org. So now you take your public address and you're going to input it here. You just use your fingers and input it in. And it's only 34 characters. Take your time. And it's also a reminder on the base 58 check. If you make a typo, so here's the correct one typed in, but if you make a typo here, it's not going to pull up an address, and that's due to the base 58 check we covered previously. This is a built-in typo catching error check is what the base 58 is. It's going to constantly check your accuracy for you. So you're only going to be allowed to proceed if you enter a valid address. It has a way to check that. So if you just mess up any one of these characters, even just by a little bit, it's going to catch it and it's going to know it's not a correct address. It's not going to let you proceed. So it's a very user-friendly feature within Bitcoin. And so once you're ready to send, you might be given the option to adjust priority. These have to do with miner fees, which we'll cover in the future. Today, it doesn't really matter which one. You can just pick the slowest one. It's not going to impact the rest of the video. And if this is your first time doing this, you will be asked some questions about your identity, where you live. You'll have to upload a picture of your driver's license or some kind of ID. This is very common. Any transaction along these lines through one of these apps is going to require that of you. It only takes a couple minutes. So assuming now that you've completed the transaction, so now we have Bitcoin on its way to our own address. And so go back to our Blockchain Explorer. So go back to your Blockchain Explorer and you can check your address now. And wait about 10 seconds after you send the Bitcoin to check this, and you're going to see one of 3 statuses. So number 1, you're going to see an address that has no change, no activity. This means that Venmo or Cash App or whoever, they haven't sent their transactions yet. Sometimes they bundle them all together every 30 minutes. Sometimes they send them right away. It just depends on the app and the time of day. So you might see that for 30 minutes or an hour. You might not. Then you might see a situation where there's no balance at all in your address, but you can see some activity down here. So this means the transaction is in the network. It's on its way to the blockchain. It's just going through some intermediary steps. Or number 3, you're going to see a balance here and you see the transaction. This means that you have an address with Bitcoin on it on the blockchain. So it's all just going to depend on where your transaction is at within the network, on which one of these you're going to see at the Blockchain Explorer. So now we're going to walk through and do a little high level each step of what is happening. So first, on a full node, the app that you're using, Venmo, Cash App, whatever, they have their own full node that they're interfaced with. And what this means is this app has gone to bitcoin.org and they've downloaded the Bitcoin Core software and they're running a Bitcoin node on their computer, which comes with a history of the blockchain. And then these 2 items here, which we're going to spend more time on in the future. Also, when you download and start the Bitcoin software, it's going to actively seek out and link up with all the other full nodes and nodes on the Bitcoin network. And right now there are about 20 to 1,000 nodes. Each node has a connection between all nodes around the world. So now the app that you use, they have a full node. They also have their own public address with Bitcoin at that address. So they're going to use their private key and they're going to create a digital signature in a transaction to send you your Bitcoin. The digital signature is what they use to prove ownership of the Bitcoin at that public address. And they're going to broadcast this transaction, which is going to spread and propagate itself throughout all of the Bitcoin network. And most nodes are going to receive it and then go through the process to check if it's a valid transaction, the signature is correct, the Bitcoin at the address hasn't already been spent, and a few more things. And if it is a valid transaction, each node is going to add it to what's called their mempool. And this is where transactions go that are waiting to be included in a block. And that you can start to see a little bit of what the term consensus is about now. So each full node is going to roughly have the same mempool contents. It's going to be different because you also have latency. It takes a few seconds for this information and data to spread around the globe. So the mempools are not going to be exact, but for the most part, they have a good rough consensus. And again, if you see this on your blockchain explorer and at your address, no balance, but a transaction's pending, this means you've made it inside of the mempool. So now the Bitcoin miners come in and they're going to pull the transactions out of the mempool, and they're going to start working on, because they're working on the next block. So they have a block template, it's got transactions in it. They'll throw your transactions into this block, and what they do is continuously adjust this information and run it through a hash function, and they try to land on a target hash result that's got a certain number of leading zeros. This is very critical. We're going to spend a bunch more time on this, but they're constantly rehashing to achieve this. And the first miner that finds this now has a block that the nodes are going to accept, and this block includes your transaction. So this miner takes this successful block and is going to push it out, and again, it's going to find its way all over the network. And each node is going to verify now that this block is valid, has the right hash value, and there's some other aspects too that each node is going to verify. And if it's valid, this new block gets added now to the blockchain. And your Bitcoin is represented in two locations. It's represented at the address on the blockchain, but also this transaction that went to you, the hash of that is called your transaction identifier, and that's also stored on what each full node has in a UTX data set. So your Bitcoin is represented in two different places. And this is also something that we're going to come back to in the future and spend a good amount of time on, as it ties into accounting and accounting methodologies. So now when this happens, when you've made it on the blockchain, you're going to see at your blockchain explorer, you now have a balance and you have your transaction. Usually this arrow means that it's confirmed. You now have a transaction that's inside of a block. You have Bitcoin at your own address. So here's your public address. You now have Bitcoin on it. And as long as you keep your private key safe, you're the only person in the lifetime of the universe. I mean, the sun will go out before this happens. You're the only person who will ever have this key, and the only person who can prove ownership of the Bitcoin at this address by digitally signing it with this key. You're the only person that can run transactions off of this address. So to recap, the transaction that was sent to you by Venmo or Cash App or whoever, they took the Bitcoin at their public address, they digitally signed it with their private key, and they broadcasted it to the entire Bitcoin network. Each full node on the network verified the transaction, sent it to the mempool. Miners pulled it from the mempool, added it to the block they were working on. One lucky miner out there found the right hash value, created a new block with your transaction and a bunch of others inside of it, and then broadcast this valid block to the network. The nodes verified it was valid, accepted it, and at this point this block was added to the blockchain.